Okay, so hello and welcome back. So we have another question here related to these DC circuits, and that is basically this problem here. So let's say that you have the exact same circuit that we had in the previous examples. You have basically some resistor over here. Let's call it, for example, R1. Call this R2, for example. You have a power supply here, and you have a resistor over here, a resistor over here, and then this is connected back to this resistor. So R1, R2, R3, and R4. R1, R2, R3, and R4. And well, the power supply V of S is 12 volts. Each of these resistors is 3.3 kilo ohm. Okay. Each of these resistors is 3.3 kilo ohm. Now, basically in this kind of circuit, since of course this is a series circuit, you know that basically the voltage of the power supply, there is a voltage drop across each of these resistors, meaning that there is a voltage drop on R1, voltage drop on R2, voltage drop on R3, voltage drop on R4. Add them all together, you will get the power supply voltage. And the voltage drop on each of these resistors is proportional to the amount of resistance of that resistor, meaning that we said before that basically V of, for example, R1 is equal to R1 to R of T of the circuit times V of S. Again, V of R2 is equal to R2 divided by R of T times V of S. Since in this circuit, basically, and so on and so forth. Since in this circuit R1 is equal to R2 is equal to R3 is equal to R4 is equal to 3.3 kilo ohm, of course, it's safe to conclude that therefore V of R1 is equal to V of R2 is equal to V of R3 is equal to V of R4. Let's call it, for example, A, for example, right? So that means that each of these, if I call it A, then there is a volt voltage drop here, a volt voltage drop here, a volt voltage drop here, a volt voltage drop here. Meaning that the voltage drop across all of these resistors would be 4 times A plus A plus A plus A, 4 times A. And that should be equal to the power supply voltage, V of S. And therefore the voltage drop across each of those resistors, A, would be equal to V of S divided by 4. Meaning that the power supply 1/4, or you can say 1/4 V of S, right? Meaning that the voltage drop across each of these resistors is 1/4 of the power supply voltage. And this would happen regardless of the resistance values, as long as the resistances were all the same resistors. Meaning that, for example, even if you had all of the resistors as 2.2 kilo ohm, still the voltage across each of those resistors would be 1/4 the power supply voltage. If each of the resistors you take as 1 ohm, again the same thing happen. Each of the resistors take as 10 ohm, the same thing will happen, but this is simple algebra, right? So that means that basically the voltage drop across this resistor is 1/4 of the power supply voltage, meaning that 12 divided by 4 is equal to 3 volts, right? So the V of R2 is equal to 3 volts. And by the same logic, V of R3, for example, would be equal to 3 volts, right? Now, if you put a voltmeter, in this circuit, if you put a voltmeter in this circuit, suppose that you have a voltmeter, one of those analog voltmeters that's basically, they have basically a needle over here, and they have basically this selector over here, and they have two leads over here. Usually this is the positive lead and this is the negative lead. Suppose that I put the negative lead, suppose that I connect the negative lead to, for example, this point over here. And suppose that I connect the positive lead to this point over here, right? Now, and this is a voltmeter. And this is a voltmeter. So the voltmeter, now what sort of voltage would the voltmeter show me if I do this in this circuit? So you need to basically start from this point and note down all of the voltages that you see around, that you see in your path between the positive pole of your voltmeter and the negative probe of your voltmeter. So your positive probe of your voltmeter is over here, and so over here you have a voltage drop of 3 volts. A voltage drop of 3 volts would be a negative 3 volts. A power supply of 12 volts would be a positive 12 volts. And a voltage drop of 3 volts would be again a negative 3 volts voltage. This is the voltage between these 2 points in this circuit. And therefore this is negative 6 volt plus 12 volt, which is equal to 12 minus 6, which is equal to 6 volts. Which is equal to, basically 12 minus 6 is equal to 6 volts. So the voltage between these 2 points in this circuit is simply 6 volts, and the voltmeter would show you 6 volts, positive 6 volts of course, because you have put the positive pole over here, negative pole over here, and this side of the circuit of course logically is positive because it's connected to the positive pole of the power supply. And this side of the circuit of course is negative, and so you have connected negative to negative, positive to positive, so you would read positive 6 volts here. That's a good question that basically I wanted to discuss. Now, the next question that we have here is basically a question related to voltage divider network. So in a voltage divider network, the total resistance should be large to minimize current range, should be as small as the, let me read the question myself. Okay, so the next question that we have, let's suppose that we have a circuit here which is basically a power supply essentially connected to 4 resistors, in series. So you have these 4 resistors connected in series, call it for example R1, R2, R3 and R4. Let's assume that there is no power supply here. Let's assume that the power supply is 18 volts. Let's assume that the power supply V of S is equal to 18 volts. And basically let's assume that R1 is equal to 100 ohm. Let's assume that R2 is equal to 22.0 ohm. 22.0 ohm. R3 is equal to 33.0 ohm. 33.0 ohm, and R4 is equal to 47.0 ohm, right? Now we want to know what is the voltage, what is, if you basically connect a voltmeter, if you connect a voltmeter between these 2 points, what would you read? What is the voltage between these 2 points, right? So to basically measure the voltage between these 3 points, there are basically 2 ways that you can do it, right? I will discuss both the ways so that we learn how to basically deal with these circuits. Okay, so to calculate basically the voltage between these 2 points in this circuit, you can basically calculate the voltage drop across R1, the voltage drop across R2, and the voltage drop across R3, and then add them together to get the total voltage drop across these 2 points, and then that would be, well, the voltage between these 2 points, right? That you can do, or you can actually basically calculate the equivalent resistance of these 3 resistors, and then calculate the voltage drop across that one resistor, and that would be still the same voltage between these 2 points. So now if I calculate the voltage drop across R1, V of R1, that would be equal to basically R1 divided by basically R of T times V of S, which is equal to, for example, 100 divided by 100 ohm divided by basically, this is the same thing as 22 plus 33 is equal to basically 55. 55 plus 47 is equal to 12, 1, and 9, 10, 102 plus 100 is equal to 202. That means that the voltage across the equivalent resistance R of T in this circuit is equal to 202 ohm, right? So 202 ohm, you have the total resistance times V of S. So 100 divided by 202, and V of S is equal to basically 18 volts. Is equal to 18 volts, and that would be equal to, for example, something like for example 100 divided by 202 times 100 divided by 202 times basically times 18, which is basically, I'm going to take, for example, 2 significant figures, 8.9 volts, for example. That would be 8.9 volts. So 8.9 volts we have there, or basically, since the voltage is basically expressed in up to basically the ones basically place value, I'm going to call it basically 9 volts. 9 volts. Now V of R2, for example, would be basically again R2 by R of T times V of S, which is equal to again 22 divided by 202. 22 divided by 202 would be basically 22 divided by 202 times 18. I'm going to call it 2 volts. I'm going to call that basically 2 volts. And V of R3 is basically R3 divided by R of T times V of S, which is equal to basically, well, 33 divided by 202 times 18 volts, which is, let's call it 3 volts. So you have the voltage drop here, the voltage drop here, voltage drop here. If I add these 3 voltages together, V of R1 plus V of R2 plus V of R3 is equal to 9 plus 2 plus 3, which is equal to 5 plus 9 is equal to 14 volts, although these are negative voltage drops. Depending on how you connect your voltmeter to the circuit, you read either a negative voltage or a positive voltage, but the magnitude of the voltage would be 14 volts. Another way that you can solve the same problem is that if you take basically R1 plus R2 plus R3, the equivalent of these three resistors, that would be 155 ohms, right? And therefore V of basically point, for example, A and point B, V of AB would be equal to basically R1 plus R2 plus R3 plus R3, I don't know why I write my R's this way, divided by R of T in the circuit times V of S. So that's 155 divided by, which would be the same thing as basically 155 divided by 202 times basically 18 volts, which is equal to basically 155 divided by 202 times 18. That gives me 13.8 volts. I'm going to call it 14 volts, which is exactly the voltage that we got here. And therefore the voltage is going to be 14 volts, right? So that's another typical problem here that you need to be able to solve. And the last problem here is basically let me read the problem. Okay, so now this problem is about building voltage divider networks or voltage divider basically resistors, meaning that connecting a couple of resistors in series so that you get the required voltages in a circuit, meaning that, for example, let's say that you have 4 resistors over here. You have these 4 resistors over here, and they are connected to a power supply. For example, let's say that this is positive, negative, right? Now let's call this R1, R2, R3, and R4, for example. And let's call this V of S. Suppose that this power supply is 12 volts, and you want basically some voltages as 3.0, 6.0, and 9.0 volts. 3.0 volts, 6.0 volts, and 9.0 volts. And the last voltage would be, of course, 3 plus 6 equal to 9, 9 plus 3, 6, and 9. Now there's a problem here. There is a problem here because the voltages are more than the power supply. 3 plus 6 is equal to 9, 9 plus 7 is equal to 18. 18 is greater than 12. So let's make this power supply, for example, I don't know, 24 volts, for example. Let's make this power supply 24 volts. Right, so now if we get these voltages here, that would be basically 9 plus 9 is equal to 18. The rest of the voltage would be, for example, on R4. And but then you need to basically make sure that basically the resistors that you put together, that basically create basically that draws some current from your power supply, of course, and that current has to be, of course, accounted for in your circuit, and that has to be allowed in the circuit, meaning that your power supply has to be able to actually deliver that current. Let's say that the allowed current is for example 200 milliamps. If the allowed current is 200 milliamps in this circuit, and so basically what sort of resistors would you choose so that these voltages are basically so that you get these voltages in your resistor network. So in order to do that, what you can do is that since the allowed current is 200 milliamps, I set the current as at 200 milliamps, and I write the Ohm's law V is equal to IR for the whole circuit. And since my voltage is 24 volts and my current is 200 milliamps, 200 into 10 raised to power negative 3 amps, and the amount of resistance that I need in total would be R, which is equal to 24 divided by 200 into 10 raised to power negative 3 in ohms, which would give me 24 divided by 200, which is the same thing as 0.12 into 10 raised to the power negative 3, which is equal to 0.12 into 10 raised to the power 3 actually, because this goes to the numerator. And so you have 120 ohms, right? So that means that that R of T in this circuit would be equal to 120 ohms. If I use if the total resistance in the circuit becomes 120 ohms, then based on the voltage that I have on my power supply, the current becomes 200 milliamps, and then the current problem is taken care of. Now, since the current problem is taken care of, now I need to choose basically the voltage, the value of the resistances, meaning that the voltages that I get on these resistors would be 3.0 to 6.0 to basically 9.0. And the last voltage would therefore be, this is 18 plus 6 is equal to 24, right? So that means that this ratio has to be basically the resistors have to be in the exact same ratio, 3 to 6 to 9 to 6, R1 to R2 to R3 to R4, so that you get basically 3 volts on R1, 6 volts on R2, 9 volts on R3, and then eventually 6 volts on R4. And that should be basically, this should be basically R1 to R2 to R3 to R4, right? So this ratio has to be there. Now let's use the same ratio and see what happens if we actually choose a couple of resistors, and you need to, of course, make sure that the resistors that you choose, the total amount of resistance is not higher than 120 ohms, right? Meaning that if I take R1 as 3 ohms, and R2 as, for example, 6 ohms, and R3 as, for example, 9 ohms, and R4 as, for example, 6 ohms, that would be 15 plus 9 is equal to 24 ohms. That's well below basically 120 ohms, right? And if I do that, so that was 6 plus 9 is equal to 15. 15 plus 9 is equal to 24 ohms. So in this case, R of T is equal to 24 ohms, right? 24 ohms basically gives me, actually the resistance has to be above this value, right? Because if the resistance is 24 ohms, the current goes higher than basically 200 milliamps. Because if I have 24 volts over here, V is equal to IR would give me basically 24 is equal to I times 24, and that would be basically 1 amp. That would be 1 amp. So that means that you have to go not below 120 ohms, but you have to go above 120 ohms, so that the current comes below 200 amps, or maximum 200 milliamps. Which means that this resistors that I have chosen here, that actually doesn't work, right? So I have to therefore go for example, multiply each of these, for example, multiply R1 by, so that the resistance has to be above 120 ohms. Above 120 ohms. Meaning that, for example, I multiplied these by 100, that would be, or by 10, for example, that would be 30 plus 60 plus 90 plus, or by 5, for example. By 5 would be 15 to basically 30 to 45 to 30. And that would give me basically 60 plus 105, 120 exactly. That gives me exactly 120, I suppose. And the current remains exactly at 200 milliamps. So that's 60, 105, 110, 120. So this would work, for example. Meaning that, and as you saw, I multiplied each of these numbers by a factor of 5. So 5 times 3 is equal to 15, 5 times 6 is equal to 30, 5 times 4 is 45, 5 times 6 is 30. That means that R1 is equal to 15 ohm, and R2 is equal to 30 ohm, and R3 is equal to 45 ohm, and R4 is equal to 30 ohm. So R of T would be equal to 15 plus 30 plus 45 plus 30, which is equal to exactly 120 ohm. Exactly 120 ohm. Now if I write the Ohm's law for the whole circuit, V is equal to IR, 24 volts is the same thing as basically I times basically 120 ohms, and therefore I would be equal to 24 divided by 120, which is the same thing as 24 divided by 120, which is the same thing as 0.2 is equal to 0.2 amps, which is equal to 200 milliamps. You can still go a little bit higher and take, for example, multiply each of these numbers by a factor of 6, for example, in which case your current will come a little bit lower, right? And so now these are the resistor values that we have chosen, and as far as the current is concerned, it works. The values work. Now let's see if we actually get the same voltages on the resistors R1 through R3, right? So V of R1 in this case would be R1 to basically R of T times V of S, so which would be equal to R1, which is equal to 15 ohms, to basically R of T is 120 ohms, times V of S is equal to 24 volts. That gives me basically 15 divided by 120 times 24. That is exactly 3 volts. That is exactly 3 volts, which is basically what we were looking for here. And V of R2 would be equal to R2 divided by R of T times V of S, which is equal to basically 30 divided by 120 times 24. That's 3 to 12, which is 1/4. 24 by 4 is equal to 6. That is exactly 6 volts, which is what we wanted to get here. And V of R3 is equal to R3 divided by R of T, which times V of S, which is equal to, over here, what is R3? R3 is equal to 45 ohms. 45 by 120 times 24, that is, what is 9 divided by 120 divided by 10 is 12, divided by 5 is 60, right? 24, I'm sorry. 120 divided by 10 is, divided by 10 is 12, divided by 5 is 24. 24, and divided by 5 is 9. 3 times 8 is equal to 24, so 3 and 8. And again, 8 times 3 is equal to 24, so that's 24, 8 is equal to 3. And so 3 times 3 is equal to 9 volts. And over here, exactly 9 volts I'm getting on R3. And the rest of the voltage goes to the last resistor there, right? So that's basically how you build a voltage divider network using resistors, right? Now, in the next chapter, we are going to talk a little bit about resistors. And if I haven't, of course I have mentioned this before, but my goal here is to essentially get us to a little bit about radios and power supply circuits and transistors and work with them, although for now we need a little bit of basically theory. Once we have done enough theory, then we will do a little bit of practice as well. So I'll see you in the next video, and thank you.